Hey everyone, Mr. Skelton. We are back at it to start Unit 6, and this is Lesson 1. Today we're going to be focusing on one thing and one thing only, and that is dealing with, more specifically, writing exponential growth functions. You've dealt with exponential growth before in some of your algebra classes. If you just think about it, we're talking exponential, so we're talking about exponents, and we're talking about growth, so something that's increasing. And obviously functions, we're going to have y equals with an x value in there, so we're talking about functions that are growing exponentially. And so I got a couple of situations on these slides to kind of ease you into this and try to give you something to associate when you're thinking about exponential growth and decay. We'll get into decay later, but right now we're going to be just focusing on growth. So here's a couple situations. Here's the first one. So this is an allowance proposition for you back in the day when you were younger. Maybe, I don't know, maybe you still earn an allowance. That would be awesome if you're in high school and you're still earning allowance. That'd be great. But here's a proposition. This is just going to be for the year. I didn't specify in the directions. This is just for a year. So here's proposition A. Proposition A, your parents come to you and say, okay, we're going to give you $100 every week, no matter what, for your allowance. Would you be okay with that? You got two situations here. So we take our $100. Got 52 weeks in a year, right? And so we're just going to have $5,200. And, you know, that's not a bad sum of money. I would take it for sure. Proposition B, your parents say to you, okay, here's the second situation, and you get to choose which one you want. You get a penny the first week, and it's going to double every week. So let's go through this scenario, and really proposition B here is a way to show you how exponential growth functions kind of come together. And so let's go through this situation. So week 1, you just get a penny, right? So after 1 week, you got a penny for your allowance. Doesn't seem like a lot, but you got a nice copper penny there for you. So the second week, you get a penny, and key word here is it's doubling, so we're just going to times that by 2. And when we times that by 2, we're going to get a total of 2 cents. Oops, 0.02. 2 cents. So after 2 weeks, you're at 2 cents. Now, it's doubling every week. So after the third week, I take my penny. I need to times it by 2, but I'm really timesing it by 2 twice, right? Because it's doubling every week. So I had a penny, I doubled it, but then I need to double what I doubled. So it gets doubled twice, and that's going to give me 4 cents. We'll go to week 4. I start with a penny. It gets doubled. How many times is it going to be doubled in week 4? It's going to be doubled 3 times. That penny got doubled once, twice. This will be the third time it gets doubled, and that'll give you 8 cents. So after a month, right, this is the weeks right here, after a month, 4 weeks, you've made 8 cents. So you may be thinking, I don't know if I want to go down this road. Well, let's keep going. I'm going to put a space here, and let's just go to 52. So you can kind of look at a pattern here. There's really a exponent of 1 here, and so if it was week 2, it had an exponent of 1. If it was week 3, it had an exponent of 2. If it week 4, it had an exponent of 3. So in week 52, we're going to have 1 cent that was doubled 51 times. Now, if you take your calculator out, you're going to find out real quick. We've got to do order of operations. So 2 raised to the 51st power is a massive number, okay? And then we're going to times that by 0.01. And so I basically get 2.25 times 10 to the 13th. Now, if I take 2.25, and this is scientific notation right here, I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh my goodness, wrong. Putting in all my zeros here. And I got to put my commas in 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Let's see, it's 22,500 billion dollars after the 52nd week. So that's not even the total. That's just in week 52 that you've earned. So if your parents ever give you this proposition, you want to go there. 22 trillion probably come close to covering our national debt. But that's steadily increasing, exponentially increasing as well, so who knows. But what I really want you to focus on in this problem here is this. This is representing exponential growth. This is a function. I could easily put a y in here, and this is the equation that's going to give us exponential growth. Okay, so let's take a look at another situation here. So this is called the rumor weed. So here's basically what we're going to say. We're going to say this is we're at Homestead High School, okay, and we're going to one person is going to start a rumor, and it's going to triple every period. Okay, so let's figure out after 7 periods how far that rumor has spread. So before the day starts, I'll call that 0 period. But before the day, only one person knows the rumor. So put people. One person. After first period, that rumor has tripled, right? So we start off with one person and it's tripled. After second period, that rumor has tripled. So 3 people have to tell 2 more people, including the people who are above it. So that's going to triple. So that's going to become a 9. So how do we get that? Well, because it's tripling, we're taking, this has been tripled now twice, right? We went from 1 and it tripled again to 9. So again, we tripled it once, we tripled it twice. So after 3 periods, that would become 27. 1 times 3 to the 3rd, because that tripled, and so on and so forth. And so if we get down to 7th period, okay, how would we find that answer? It'd be 1. We started with one person, which that rumor tripled 7 times throughout the day, 1 for each period. Started out with one person, it tripled 7 times because there's 7 periods. So we would just take our calculator out and go 3 to the 7th and times that by 1. So basically at the end of the day, over 2,000 people heard that rumor. So 2,187. Really, that's probably pretty close to Homestead's population. We're at about 2,200, I believe. Okay. And again, what I want you to focus on is how we're getting that number. This is an exponential growth equation. So let's kind of talk about on this next slide what you're looking at. I'll try to make sure that highlighted part is still visible. So this is right here. This is exponential, what we call the exponential growth in decay equation. And here's what each part means. The first part, the A, is our beginning amount. So if you take the rumor equation that is still visible on your screen, what did we start with? We started with a 1. This would be like y equals 1 times 3 is our growth factor. So that second number is the growth factor, whether it's tripling or doubling, right? If you go back to the first page, you look at what I have highlighted, the second number are all 2's. Why? Because it was doubling, okay? And so your B value is the growth factor, which means what it's growing by, and then the X is just going to be how many times that growth factor is exponentially increasing, okay? And so that's the equation that we're going to use, and let's apply that now to another problem. So here's another situation where we have money in the account. You have $5,000 that you put into an account in the year 2000. The account earns 8% interest. What will it be worth in 2025? So you're thinking in 25 years, how much is that going to be worth? Okay, so if we go with the equation, or if you just go from what you remember for the first 2 examples, what are we starting with? We're starting with our A value, which is 5,000. Okay, and we're going to times that by its growth rate. Now, your money is earning 8% interest. Now, a lot of students are going to want to put 0.08 in here for B, but we have to be careful because that would just be taking 8% of 5,000, and that's not what we want to do, right? We want this 5,000 to grow 8%. So what we can think about is this: we want to take 100% of the $5,000 and add to that 8% interest. So really, we have 108% interest on our 5,000. So this becomes 1.08. because you would move the decimal place over 2 spots. Any percentage gets turned into a decimal, you move it over 2 spots to the x power, okay? Now, if that's not making sense to you, I just want you to think about it real quick. If I had the equation y equals 5,000, okay, and I just put a 1 in here, if I just put a 1 in there, 1 is obviously bigger than 0.08. 1 would just represent 100% of the 5,000, because if I put like, okay, after 1 year, okay, I would just have 1 to the first power, which is 1. I would just have, if I put a 0 in there for the exponent, so what I started with, anything to 0 power is 1. 1 times 5,000 is 5,000, all right? So we have to have 1.08 for our percent, because we're including the 5,000% that we started with, okay? The other way you can think about it is if you did 5,000 and you just times it by 0.08, that's $400. Well, obviously that wouldn't be our answer. That's 8% of the 5,000. So if you just put 0.08 in here, that's not going to work, because it would just give you the $400. So here's our equation, and now we want to know after 25 years, so we would just plug in the 25. For our x, and we would take our 1.08 and we would raise that to the, I'm going to put it in parentheses, 1.08, and raise that to the 25. It equals, and then I'm going to times that by 5,000, and I get 34242.37, 123. So I'm going to get basically $34,242.37. Okay. We're going to switch gears a little bit here. Now I'm going to ask you to actually write the equation of exponential growth giving 2 points on a line. Now you've done stuff like this with linear equations, where you create a system of equations and you write out the equation. But again, our end product wants to look, we want to come up with an equation that looks like this. So how do we do that? Well, this is a little quirky, but there's a lot of different ways you can go about doing this. I'm going to show you what I think is the easiest. The first thing that you want to do is you want to identify the larger point with the values, okay? So identify the larger point. So right here, this 5, 16, those numbers are obviously larger. The second thing you want to do is we want to plug those in to our equation of y equals a times b to the x. So let's do that. Our 16 is our y value, so I'll get 16 equals a times b, 5 is our x to the 5th, okay? The third thing we want to do is we want to plug in the second point to the same equation, okay? And so that is going to be, and I'm going to write it underneath it. You always want to write it underneath, under. So I'm going to have a 2 equals ab squared. Now, you can see here I kind of have a system of equations. And what we've done in the past is we've always added these or subtracted these, right? Like 16 minus 2 is a minus a, and blah, blah, blah. What we're going to do a little bit, which is a little bit different, so this is kind of the step 4, is we're going to divide. We're going to divide those two. So basically we're dividing these. So what do we get? 16 divided by 2, 8. A divided by a is just 1. Okay, so we just get a 1 there, but I'm not going to put a 1, and otherwise they just divide themselves out. And then we have b to the 5th divided by b squared. And remember what we did in semester 1 with exponents, we subtract those, so you get b to the 3rd. And we're going to solve for b here, so we're going to take the cube root of 8, which hopefully you remember is just 2. And we're going to take the positive root here. So I got b equals 2. And then to find your a value, we're just going to plug this into either one of the two original equations. I'm going to plug it into the second one here. So I'm going to have 2 equals a times 2, plugging in 2 for b, squared. So I get 2 equals basically 4a, right? 2 squared is 4 times a, and then I'm going to divide by 4, so I get a equals 1/2. So there's my a value, there's my b value, and again, the whole point of this is to find an a and a b value so we can write our final answer, which our final answer is going to be y equals 1/2. My b value was a 2 times 2 to the x. So given 2 points, we were able to write the exponential growth equation for this function. What does this mean? It means that this function started out at 1/2 and doubled. That's what what's happening there. Okay? I have the last problem here on the back. I'd like you to try this one on your own. So go ahead and hit pause, see what you can do, and then check back with me. Okay, so same problem that we just did. Again, locate the point with the larger numbers, which is here, and we're going to be focusing on the function, the exponential growth function. So I'm going to have 10.125 equals a times b to the fifth, and then I'm going to have a 3 equals a times b to the second. And so again, we're going to divide these. We're going to divide these out. So I got to take my calculator out and get 10.125, and I'm going to divide that by 3. I got 3.375 equals, my a's basically cancel out, and I get b to the third. So I got to take the cube root of that. You can do that a couple different ways in your calculator. I'm just going to raise it to the 1/3 power. It's the same thing as taking the cube root. And I get 1.5. So 1.5 equals b. And then again, you can plug that back into any of the two originals. I'll plug it into this bottom one here. So I'm going to plug that b in there. I'm going to have 3 equals a 1.5 squared. So I'm going to have 1.5. I'm going to square it. And then I'm going to have 3 equals basically 2.25a. So I'll divide both sides by 2.25. So 3 divided by 2.25. And I get a equals 1/3. And my whole idea behind this is to write the equation in exponential growth form. And so I'm going to have 1/3. Actually, it's not 1/3. It's 1.3 repeating. Sorry. So that's 4/3. So let's go 4/3. Did my math wrong there. And that's going to be my b value of 1.5 to the x. And there's my answer. Okay? So again, with the video notes here, if you need to, at any point in time, go back and rewatch an example, that's fine. Also, if something doesn't make complete sense to you just from watching the video, that's probably going to happen more times than not. And that's when you can come into class, and we have the entire class period to kind of go over these notes. If you want to, I can reteach something to you. We just have to make sure that we can communicate openly and have some good conversations, and make sure that before you walk out of the door in class that you feel solid about the concepts that were taught in lesson 1. So I expect your questions when we come to class and start working together, and hopefully we can have some success when we're working on the assignment. All right? All right, have a good one, and I'll see you next time.